Good morning, students. Important topic: L'Hospital's rule. L'Hospitals, HOS. L'Hospitals. If the limits leads to an indeterminate form such as 0 by 0, infinity by infinity, infinity to the power of 0, 0 to the power of infinity, right? Those comes under L'Hospital. We can apply L'Hospital rule to find the limit of those problems, right? Other indeterminate forms are infinity minus infinity, 1 to the power of infinity, infinity to the power of 0, 0 to the power of 0, 0 into infinity. All these are called indeterminate forms. Okay, now the generalized mean value theorem. The previous one is the mean value theorem. This is called generalized mean value theorem. What is the state and prove general mean value theorem? Generalized mean value theorem. You have to write the statements. If f and g are two continuous function on closed interval a comma b and f is differentiable on open interval a comma b, then there exists at least one x and one x lies in between a and b. That means x belongs to a and b. It may be c, it may be other value which is lies in between a and b only, such that f dash of x by g dash of x is equal to f of b minus f of a by g of b minus g of a, right? Now state and prove means you have to write the statement and you have to prove this statement. Now what is the given data? Read the statement. F and g are continuous function. F and g means f of x and g of x are continuous functions on closed interval a comma b. What about differentiation? Yes, it is differentiable on open interval a comma b. F of x and g of x are differentiable on open interval a comma b. Now we have to prove this condition. To prove that condition, I am going to define a function which is a new function h of x is equal to this one, f of x into g of b minus g of a minus g of x into f of b minus f of a. Here we know that f of x is continuous, which is constant. G of b means constant, no? That means in the function, in the place of x, we are substituting x is equal to b. You will get a constant. In the place of x, we are substituting a. That means again on simplification, you will get a constant. Here also this is constant, this is constant. Now here function, a continuous function into a constant is always a continuous function. Now what is g of x? Continuous function. Now this value is constant. Now therefore this entire thing is a continuous function. Now continuous function minus this entire thing is continuous, no? Minus this one. Continuous function minus continuous function is always continuous, right? Now we are finding h of a. At x is equal to a, what is the value of the function h of x? Now h of a is equal to, in the place of x I am substituting a. Now on simplification I got this result, f of a g of b minus g of a f of b, right? Now similarly at x is equal to b we are going to find the value of h of b. Therefore h of b is equal to, in the place of x we have to substitute the value of b, right? And I got this result. On simplification, see, minus we are multiplying inside and we are rearranging in a proper order and we are getting this equation number 2. From equation 1 and 2, what is your conclusion? Both are same. That means h of a is equal to h of b, right? And what is Rolle's theorem statement? Rolle's theorem means if f of x is continuous and differentiable on open interval a b and the condition is f of a is equal to f of b, then there exists a value c lies in between a and b such that f dash of c is equal to 0, no? Right. In the same way, here h of x is continuous function, h of x is a differentiable function and h of a is equal to h of b. Therefore, by Rolle's value theorem, see, h of x is continuous on closed interval ab and also differentiable on open interval ab and the condition is also satisfied. What is the condition? I told you in the previous video, in Rolle's theorem f of a must be equal to f of b. Here h of a is equal to h of b, right? So by Rolle's theorem h dash of c is equal, h dash of x is equal to 0 where x is at least one value of x in open interval a comma b. It may be c or something. Now what is h dash of x? We know that h of x is equal to this entire thing, right? Now if you differentiate this one, what you will get here? Differentiation of f of x is f dash of x, which is a constant coefficient of f of x. We can take it outside. Now here the coefficient is f of b minus f of a. Differentiation of g of x is g dash of x, right? Now therefore f dash of x, sorry, h dash of x is equal to 0, no, by Rolle's theorem. What is h dash of x? H dash of x is this one, using the equation definition. F dash of x into coefficient, g dash of x into coefficient is equal to 0. Therefore, here if you transpose this to right hand side, you will get g dash of x into f of b minus f of a, and then now g dash of x transpose to left hand side, and this coefficient becomes in the denominator to the on the right hand side. F dash x by g dash of x is equal to f of b minus f of a by g of b minus g of a for some x belongs to open interval a comma b. This is called generalized mean value theorem, important one. Now this result reduces to a standard mean value theorem when g of x is equal to x. Now suppose, see, if g of x is equal to x, what is the g dash of x? 1, no? That means this denominator becomes 1, right? Now f dash of x is equal to g of b minus, sorry, f of b minus f of a by, now g of x is equal to what? X. G of b is equal to what? B. G of a is equal to what? A. G of 1 is equal to what? 1. G of 2 is equal to what? 2, like that. Now in the denominator what you will get? B minus a. Instead of g of b is equal to b. Now g of a is equal to a. Then what you will get here? F dash x is equal to f of b minus f of a by b minus a, which is nothing but a mean value theorem, right? This mean value theorem is a generalized case of generalized mean value theorem, right? Now see, problems on L'Hospital rules. These problems are very, very important. Now find the limit extends to 0 sin x by x. What we have to do? Simply, first of all, in the rough work, direct substitute the x value. What is x value? 0. In the rough work, I am substituting sin 0 by 0. If you are applying the limit, no need to write the limit. Remember this one. Sin 0 is 0 by 0, which is in an indeterminate form. If it is an indeterminate form, we have to differentiate the numerator separately and the denominator separately. Now see, this is the first problem, no? That's why I'm writing the operator, d by dx operator. Differentiation of sin x is cos x. Differentiation of denominator x is 1. Now a limit extends to 0. What I'm getting here? Cos x by 1, that is cos x only. Now apply the limit cos 0, right? As extends to 0, no? 0. Cos 0 is 1. 1 by 1 is 1. Therefore, limit extends to 0. Sin x by x is equal to 1. Right. Next problem. Limit extends to 0. Cos x minus 1 by x square. Right? Cos x minus 1 by x square. Now if you apply the limit directly, cos 0 is 1. 1 minus 1 by 0 square. That means 0 by 0 form again. Indeterminate form. Right? Now in that case, what we have to do? Simply we have to differentiate this one. Right? Now differentiation of cos x minus 1, differentiation of x square. Differentiate numerator separately and also denominator. Right? Differentiation of cos x is minus sin x. Differentiation of 1 is 0. Differentiation of x square is 2x. Right? Now on simplification, minus sin x by 2x. Now again, substitute the limit in the rough work. Again sin 0 by 0. Sin 0 is 0. Again 0 by 0 form, indeterminate form. Right? Now again what we have to do? Again we have to differentiate. Now differentiation of minus sin x is minus, we can take it outside. Differentiation of sin x is cos x. Differentiation of 2x is 2. Now minus outside. Now limit extends to 0. Minus cos x by 2. Now if you apply the limit, cos 0 by 2 with minus sign. Cos 0 is 1. Therefore minus 1 by 2. Therefore the limit value of limit extends to 0. Cos x minus 1 by x square is equal to 1 by 2. Right? Now these are the homework problems. Next one, limit x to the power of x as extends to 0. Now again, here we have to remember this formula. What is x is equal to e log x. X is equal to e log x. I am replacing that one. Here in the base I am writing e power log x whole power x. That is multiplying, no? E power x log x. Only base. At the base I am substituting e log x value. See here. right? Now log m, this is powers we have to multiply, therefore x log x I am getting, x tends to 0. See, e to the power of, in the place of x, 0 log 0, e to the power of 0 into 0 into something is 0, e power 0 is 1, therefore limit x tends to 0, x power x is 1. Similarly, we can prove this one. Limit x tends to infinity, x to the power of 1 by x is also 1. Limit x tends to infinity, 1 minus 1 by x whole power x is also e power minus 1, which is nothing but 1 by e. Right? Now, next problems. So I am posting it once again. Limit, we know that, this is already repeated now, sin x by x is equal to, which is 1, and the cos x minus 1 is sin minus 2x by 1, which is nothing but minus 1 by 2. Okay, done. Next one is the homework problems. Please cross check this one. Limit x tends to infinity, x square by e power 3x, given that limit x tends to infinity, x square by e power 3x is equal to, if you apply the limit directly, here infinity by infinity form, which is an indeterminate form. In that case, what we have to do? Simply differentiate denominator and also different numerator separately. Differentiation of x square is 2x. Differentiation of e power 3x is 3 into e power 3x, right? Now again, if you apply the limit, again you are getting infinity by infinity form. Therefore, once again you have to differentiate numerator separately, denominator separately. Here 2 by 3 is a constant, we can take it outside the limit. Now differentiation of x is 1. Now differentiation of 3 power x is e power 3 power x is 3 into e power 3x. Now again simplification, limit x tends to 0, 3 into 3 is 9, 2 by 9 into e power 3x, right? Now if apply the limit, now e to the power of infinity, e to the power of infinity is 1, no, right? E to the power of something, e to the power of 0 is also 1. Now sorry now here what is this? E to the power of 3 into infinity. E to the power of 0 is 1. E to the power of is infinity. 1 by infinity value is 0. Therefore, 2 by 9 into 0 is 0. Limit x tends to infinity. X square by e power 3x is equal to 0. Now you have to remember, e power 0 is equal to 1. E power infinity is infinity. Right? The next one. So these are the no need to this one already done. Now please try to solve this problem only. Limit x tends to 0, x log x, please try to solve this one, right? Next one is Taylor's, last topic is Taylor's series, right? Please, you can ignore this topic, right? You can skip this topic because it's very lengthy. There are very lengthy problems are there. It takes more than 25 minutes. Now, what is Taylor series? Before going to discuss about the Taylor series, we have to define power series. Power series is nothing but summation ak x power k, where ak is constant. A power series with a radius of convergence r greater than 0, r may be infinity, f of x is equal to summation k running from 0 to infinity ak into x to the power of k. This is called power series in x. Right? Now if you want to differentiate this one, ordinary differentiation only, f dash of x is equal to, ak is constant, no, we can take it outside. Now x to the power of k differentiation is k into x to the power of k minus 1. X to the power of n differentiation is n into x to the power of n minus 1, like that. Right? Now if you want second order differentiation, that is f double dash of x, then once again you have to differentiate this one. Then what you will get? K minus 1 into x to the power of k minus 1 minus 1, that is k minus 2. Now what I am getting here? K into k minus 1 into ak x to the power of k minus 2 is a second order differentiation. Suppose if you want to find nth order differentiation, what we have to do? F n of x is equal to n times you have to differentiate, right? Now here let f be a function defined on some open interval containing 0. Containing 0 means the end points of that interval have opposite sign, then only it possible. If f possesses derivatives of all orders at 0, then the series summation k tends to infinity f to the power of k and kth differentiation of 0 x to the power of k, the k factorial is called the Taylor's series for f about 0. Right? What define Taylor series about 0 means you have to write this definition. Now the remainder Rn of x is defined by Rn of x is equal to f of x minus k tends to 0, k running from 0 to n minus 1, fk of 0 x to the power of k by k factorial. You have to remember this definition. Define Taylor series means you have to write this one at 0. Next, for any x, f of x is equal to summation k running from 0 to infinity fk of 0 x power k by k factorial if and only if limit n tends to infinity Rn of x is equal to 0. If this is possible, then only you will get this one. Now this implies this one. Next 1 over 2 over. Next thing, Taylor's theorem. Let f be defined on open interval a comma b where a less than 0 less than b, and suppose that nth derivative fn exists on a comma b, then each non-zero x in ab there is some y between 0 and x such that Rn of x is equal to fny by n factorial into x power n. Again, it is a statement of Taylor's theorem only. Let f be defined on an open interval a comma b where a less than 0 less than b if all the derivatives fn exist on open interval a comma b and it are bounded by a single constant c, then limit n tends to infinity Rn of x is equal to 0 for all x belongs to the open interval a comma b. It is a point. Again, there is another Taylor's theorem, another form of Taylor's theorem. Let f be defined on an open interval a comma b where a less than 0 less than b, and suppose that nth derivative of the function exists, that is fn exists, and in a continuous on open interval a comma b, then for each x belongs to a comma b we have Rn of x is equal to integral 0 to x minus t whole power n minus 1 fn of t dt by n minus 1 factorial. This is another statement of Taylor's theorem. Right? Please skip this topic for the main examination. Right? This is the last topic in unit 3. Please skip this Taylor series. Now problems on Rolle's theorem, Cauchy's mean value theorem, L'Hospital's rules, those are very, very, very important. Right? Tomorrow we have physical classes. We are going to start the physical classes now. I will give the important questions and problems on Taylor series, Cauchy's mean value theorem, generalized mean value theorem, again on L'Hospital rule. Okay.